So I'm going to talk a little bit more about principal roots before we get into the video on section 6.4, and we touched on this in class, but we need to look at principal roots, which are the positive roots when we're talking about some radical functions. And let's take, for example, y equals the fourth root of x to the 12th. Where we need to be careful is when we have an even index, and when we simplify this radical, we actually get something as simple as y equals x cubed. Well, if we were to graph the function y equals x cubed, it would look like this. But let's look at what happened to the graph of y equals the fourth root of x to the 12th. So let's go to our calculator, and as you'll see, I typed in y sub 1 equals the fourth root of x to the 12th, and when I graph it, it's entirely positive. So this negative part of our cubic has been flipped over the x-axis and it's become positive. And the reason for that is whatever this radicand is, x to the 12th, whether x is positive or whether x is negative, that radicand is definitely going to be positive. And so in the case where you have an even index and you simplify the radical and you have an odd exponent and a variable is involved in this portion of the simplification, you have to take the absolute value in order to get the correct answer. So that's principal roots for you. So moving on to section 6.5, I believe we got through this slide today, but we're going to take the cube root of 125 m to the 30th p to the 20th. So we're doing the cube root. If I rewrite 125, we're going to break this apart. We're going to do the cube root of 125, and then we're going to do times the cube root of m to the 30th, and the cube root of p to the 20th. Now the first two parts of this expression are easy. The cube root of 125 is 5. The cube root of m to the 30th, we're going to do 30 divided by 3, which gives us m to the 10th. But then this p to the 20th, that one's a little bit different because 3 isn't going to go into 20 equally. So I'm actually going to break p to the 20th down, and I want to go to the nearest multiple of 3 that's less than 20. So I'm going to break down p to the 20th into p to the 18th times p squared, and this is the cube root of that. Well, the cube root of p to the 18th is p to the 6th, and then this p squared that's left in here, it's kind of a loner. It has to stay under the radical because it didn't have another buddy to help him break out. You have to have 3 p's for 1 p to be outside of the radical. So that would be the simplified form. Now we have the square root of 16x to the 4th y to the 11th. So we're going to break that down into the square root of 16 times the square root of x to the 4th times the square root of y to the 11th. But because our index is understood to be 2, we want to talk about the nearest multiple of 2 to 11. So we're going to write y to the 11th as y to the 10th times y to the 1st. Oops. So when I break this down, we get 4x squared, the square root of y to the 10th becomes y to the 5th, and then we have the one single y that's left underneath the radical. Okay, simplify the quartic root of 625 b to the 28th k to the 23rd. So we're going to do the fourth root of 625 times the fourth root of b to the 28th times the fourth root, k to the 23rd. The closest multiple of 4 is going to be k to the 20th. So I'm going to rewrite k to the 20th at 23rd is k to the 20th times k to the 3rd. So now we get 5 times b to the 7th times k to the 5th, and then we have this k to the 3rd left underneath the radical. Quotient properties of radicals is very similar to the product property of radicals. If we have the nth root of a over b, we can rewrite that as the nth root of a over the nth root of b. Likewise, if we see something like the square root of 27 divided by the square root of 3, we can rewrite that with the radical around the whole thing. So the square root of 27 divided by 3, that's the square root of 9, which is 3. But you do have to make sure to combine these that n, or your index, is the exact same number for them to be like terms. So simplify the square root of y to the 8th over the square root of x to the 7th. So the numerator is going to be y to the 4th, and the denominator, we're going to break that down into x to the 6th times x to the 1st power. So now we have y to the 4th over x to the 3rd square root of x. But as you learned last year in geometry, you don't want a radical in your denominator. So to get rid of this radical, we're going to multiply by the square root of x on top and bottom. So it's just a creative way of multiplying by 1. So now we get y to the 4th times the square root of x for our numerator, and in our denominator, we simply get x to the 4th. Part B, simplify the cube root of 2 divided by 9x. So we're going to break it up into the cube root of 2 in our numerator. And in the denominator, the cube root of 9x, I'm going to break 9 down into 3 times 3 times x. Now, when we simplified radicals, we always had to have pairs. Like if we wanted to simplify the square root of 27, that was the square root of 3 times 3 times 3. And because our index is understood to be 2, we could take pairs of numbers and break them out and leave what didn't have a pair underneath the radical. When we're talking about cube rooting something, we actually need to have groups of 3 in order to simplify it. So if I look at my denominator, I need another 3 in order to have those 3's break out of the denominator, and I need 2 more x's. So my creative way of multiplying by 1 is going to be to take the cube root, I need 1 more 3, and I need 2 more x's. So I'm going to multiply by the cube root of 3x squared on top and bottom. So in my numerator now, I get the cube root of 6x squared, and in my denominator, I get the cube root of 3 times 3 times 3 times x times x times x, and my stylus is going crazy now. So my denominator is just going to be 3x. My numerator is the cube root of 6x squared. And now we don't have a radical in our denominator. So you can try these 2 problems on your own, and we can go over them in class. So our last thing is simplifying radical expressions. A radical expression is in simplified form when the following conditions are met. The index n is as small as possible. The radicand contains no factors other than 1 that are nth powers of an integer or polynomial. The radicand contains no fractions, and no radicals appear in the denominator. So we're going to simplify this, and we're looking at 5 is on the outside. I'm going to multiply my 2 radicands by each other. So 100 times 10 is going to give us 1,000, and a squared times a is going to give us a cubed. Well, I'm cube rooting all of that, so I'm going to get 5 times 10, because 10 is the cube root of 1,000, and a is the cube root of a. So when I simplify that, we get 50a. So for this next one, I'm going to use the commutative property of multiplication. I'm going to shuffle it around. So I'm going to bring my 2 coefficients out front. So I get 3 times 2. And now I have the cube root. Now, since my index matches on both of these expressions, I can just put everything under there as the radicand. So I can take 16a squared times 4a and put that all underneath the radical. So I get 6 as my coefficient out front, and now I want the cube root of 64a cubed. The cube root of 64 is 4, so I have 6 times 4, and the cube root of a cubed is a, so this is going to give us 24a. Add and subtract radicals, so 3 squared of 45 is 3 times the square root of 9 times the square root of 5, minus 5 times the square root of 16 times the square root of 5, plus 4 times the square root of 4 times the square root of 5. So I just broke apart my radicals. And so here, square root of 9 is 3. 3 times 9 is 9. So I have 9 square root of 5 minus square root of 16 is 4. 5 times 4 is 20. So minus 20 square root of 5 plus square root of 4 is 2. 4 times 2 is 8. 8 square root of 5. Now these are all like terms because they all have an index of 2 because they're all square roots, and the radicand is exactly the same. So we have 9 square root of 5 minus 20 square root of 5 is negative 11 square root of 5 plus 8 square root of 5 gives us negative 3 square root of 5. And doing this one, if we break this down, we get 15 square root of 3 minus, if we're looking at 48, 16, that breaks down to 16 times 3. So this is going to give us minus 8 square root of 3 plus square root of 3. All of these are like terms. It's understood that a 1 comes before that 1. So we have 15 square root of 3 minus 8 square root of 3 is 7 square root of 3 plus 1 square root of 3 equals 8 square root of 3, and that's your final answer. Multiplying radicals, we're going to FOIL these. So 2 square root of 3 times square root of 3. And then outer, first times first. Oops, I should have done that one first. 2 square root of 3 times 3. So that's going to give us 6 square root of 3. Inner times inner is going to give us 9 square root of 5. And last times last is going, messed up, to give us minus 3 times the square root of 15. So when I simplify this, I get this here is going to be 6 plus 6 square root of 3 plus 9 square root of 5 minus 3 square root of 15. And that's as good as it gets for that one because we don't have any like terms that we can combine. So this last problem, if we do first times first, we get 10 square root of 5. Outer times outer, we get minus. Minus 2 times the square root of 35. Inner times inner, we get plus 20 square root of 6. And last times last, we get minus 4 square root of 42. And none of those will simplify, and none of them are like terms, and that is as good as it gets for that one. And that is it. Good luck on your homework.